All right, so let's look at this problem. According to the web, manhole covers must be a minimum of 22 inches in diameter, but can be as much as 60 inches in diameter. Assume that a manhole is constructed to have a circular opening with a diameter of 22. Men have shoulder breadths that are normally distributed with a mean of 18.2 inches and a standard deviation of 1.0 inches. What percentage of men will fit into this 22-inch manhole? So let's do problem one first. Okay. So the idea is this: shoulder widths are normally distributed with a mean of 18.2. And so that's the mean, and the standard deviation is 1.0 inches. And so if we make a manhole cover 22 inches, what percentage of men will fit in the manhole? So 22 is going to be out here. 22 is going to be out here. And so we're asking what percentage of men have a shoulder width of less than 22, right? That's what it takes to fit into the manhole, is a shoulder width of less than 22. So we need to find that area. So we're just choosing one person at a time. So we're using the method that we're most familiar with. We need to find the z-score of our critical boundary, 22 minus 18.2 divided by 1, right? Not too difficult to do. What's that going to be? 1.8, 3.8, I think. So 3.8. So that's the z-score. So if we look up in our table, 3.8, the area to the left is going to be 0.9999. So the answer is, what percentage of men will fit into that manhole? 99.99%. That's pretty much everybody, right? Okay, and notice we just were choosing one, considering one man at a time. But in problem 2, they ask us to consider a sample of size n equals 36. And if 36 men are randomly selected, what's the probability that their shoulder breadth is less than 18.5? Okay, so we're taking 36. So this is the distribution of sample means for samples of size 36. So the mean of the means is going to be the same thing, 18.2, but the standard error, or the standard deviation of the means, is standard deviation divided by square root of n. So in this case, 1 divided by square root of 36. Okay, 1 divided by square root of 36, which is 0.167. All right, so we want, what's the probability that their average is less than 18.5? So 18.5 is going to be somewhere right around there. 18.5. We want less than that. So the probability of being less than that is that area. So we proceed just like we have. But this time we find the z-score of 18.5 minus 18.2 over 0.167. And that gives us a z-score of 1.7, if we round, 1.80. All right? And so, looking up our table, to get us the area to the left of that is 1.80 in our table, 0.9641. 0.9641. So 96% of men will actually fit in a manhole that is what? 3.5 inches smaller in diameter. And so what's the probability of men, or what's the probability that their average is less than 18.5? And the answer is 0.9641. So does this suggest that we can save money by making this manhole smaller? Well, if you make the manhole smaller, from 22 down to 18.5, 96% of men can still fit in that. that's probably worth it, right? To decrease the diameter by 3.5 inches, right? Because if you decrease the diameter by 3.5 inches, right? So a 22 inch manhole, that's its diameter, has an area of 34.55 square inches. Okay, 22, if its diameter is 22, its area is, nope, let me back that up, sorry. It's quite wrong. Let's try that again. So for the bigger manholes, the area is 380 square inches. Okay, 380 square inches of material that you have to use to create the bigger manhole, all right? But if you use the smaller, where the diameter is 18.5, let's clear that out. Then you're only using 268 square inches. So you've saved basically 110 square inches, and if you're paying for iron or steel by the square inch, you're cheaper. And so look, you've gone from 99.99%, which is practically everyone, to 96.41, which is still really high. So I think it probably is worth decreasing the size of the manholes so you don't spend so much money on making them, but yet you still pretty much everybody can fit into them. And so you see, we can do the calculations, but there are reasons we want to know these things, right? Because if you don't have the ability to look under the normal curve and find these areas, you have no idea how many, what percentage of men will fit in the manhole. Yes, you might know the average width is 18.2. But that doesn't paint as complete a picture by itself without finding these areas. And so you can say things like 96% of men will fit into a manhole that's 18.5. When we're talking about, I should say, when we're talking about groups of 36. So that's the other thing. This 96.41 means that if you hire 36 random men, the probability that they will be able to fit, their average will be less than 18.5 is 96.4. Now, be careful because that's their average, and so the average is definitely going to be a little closer. You might have more. So it's truly not 90. It's not truly that 96% of men. I'm going to back up a little bit from what I said previously. It's not true that 96% of men will fit in the manhole. What we have found is that for groups of size 36, 96% of those groups will have an average less than 18.5. And so that tells you that, if you're going to hire 36 men, then there's a 96% chance that their average will be less than 18.5. That doesn't mean they can all fit down an 18.5 inch diameter manhole. It just means that's their average. So we got to be a little careful. So what I said previously was not truly correct. It's more correct now just to say that their average is there's a 96% chance. So it's not quite as clear cut that we should make the manholes smaller, but there is, but on average, for a group of 36, their average will be 18.5, 96% of the time.